Okay, then let's begin. Good afternoon. After having discussed some introductory stuff and basics last time, we will today enter the, you might say, the real topic of the lecture, step by step, liberalization of electricity markets. And, okay, I think that was not very successful. Better, okay, good. And while approaching, let's begin our journey, step by step approaching the issue of liberalization, but by discussing shortly, what do we expect from a power system or from the power industry as a whole? And there is the so-called traditional triangle of requirements, which is economy, affordability, you may say, it's reliability and its sustainability. All of these three have been there all over the time, but as you easily can see, they're not necessarily pointing in the same direction. So there are some conflicts between the three, and the weight of each of the three has varied over time, and there is also no constant or absolutely correct answer. And you will see that if we look how power systems developed in the late 19th century, you can say the biggest challenge was to get the capital for this new industry, to get energy, and of course also technology. In the late 19th century, this was a new industry. Well, you can't call it an industry, it was a new technology. Very unknown, so managing technology in itself was a challenge. And relative to demand, which was close to zero, every installation was a big investment and risk. So in the early days, you may say managing technology, and from the three, economy were the biggest challenges to build this new industry, to do the first steps. And in fact, as it was so small, nobody thought about sustainability issues. It was a very small, nascent thing. No impact, no real impact to the environment, you may say. And reliability, well, I think at that time people were happy if they made it happen and it was running some time, and maybe didn't talk about 100% reliability. If we then move a little bit forward to the 20th century, at that time networks had evolved, first applications were there. The original applications were primarily light and mechanical energy. Motors, that was the biggest application, the industrial application, and light, of course. Not much more, but it became more and more obvious that if you want to build reasonable systems, networks, this is an infrastructure business. Networks are a significant part of the overall cost. And as with all infrastructures, loading makes it more cost efficient. So looking for new applications for the same infrastructure became an issue. You may say it's still economies trying to get a better loading for the fixed cost dominated infrastructure. And in that time, people were looking for additional applications, and I usually refer to one thing that I'm not sure, I guess nobody can remember it. In the meantime, when I was young, I could still see some remainers. In these days, something was invented which was called, well, electricity for heat applications, and that was cheaper. Just because otherwise they could not have competed against the traditional sources for heat, which were at that time primarily coal and maybe wood, still in the 20s of the 20th century in private households. So they subsidized electricity for these particular applications in order to get better loading again for the infrastructure. And how do you think that they differentiate that? Well, of course, there was certainly a separate meter, but you had to make sure that you could not connect other devices to the same infrastructure. So they had a particular type of plugs and sockets, which was compatible, so you could use it also for the more expensive electricity, but not the other way around. It had a particular shape. It was not round, as we know the cylindric folds of today's socket. It was a U shape, a double U shape, carved out. And there were particular sockets for that, and they offered a cheaper electricity. And my grandparents still had one of them in their house, and I never understood what that was for until I visited university and learned a little bit about history of electrification. So it's an example that how people try to pull new applications into this sector. And it was, of course, in the private sector, it was primarily cooking, as you can imagine, and later on, much later, heating came also in the particular application of night storage. You may say in the 40s, and from then on, reliability became more and more an issue, and the simple reason for that was that electricity had become an important infrastructure for many parts of the life. So, of course, if it becomes more important, reliability matters more. And then you could see even in the 40s, well, that's, you see, in the middle of the Second World War, at least in Europe. And nevertheless, people started to think more and more about interconnection. So immediately after the Second World War, the European interconnected power system started growing, before the European Union, by the way. And there were two drivers. One was economies again, sharing reserve. So if you have a bigger system, you need relatively less reserve capacity. But the other reason was also the ability to help each other, and reliability of supply was an issue. So at the same time, electrification was quite successful. So it grew. It became an even bigger sector, and of course, the bigger it became, the more environmental implications became obvious. So environmental concerns evolved in parallel, and in the 60s, you may say, 50s, 60s, you saw the first consequences from that. And what do you think were the consequences in the, at that time, industrialized world of environmental concerns? What was the response at that time? Maybe I could also phrase the question a little bit more neutral. Which technology evolved in the 50s and 60s in power systems? On the generation side. Nuclear power, exactly. And the main driver for nuclear power was environmental concerns, because it's emission-free. Today we would say carbon-free. Nobody was discussing carbon dioxide at that time, but no local emissions, no pollution. So that was one of the main drivers. Economy was the other one, so people were dreaming of cheap and clean, you may say, energy without problems. I'm stressing that a little bit because you can easily see how the perception of things may change over time. It's still the same technology. And by the way, people did know about waste at that time, and people also did know about radiation. So it was not that they missed something. Everything that we know today was known at that time as well. And also there you can see some consequences. I'm not sure whether they're still in place. Well, I guess they are. It's not the strength of the public sector to reshape its buildings. When the new part of the university here was built in the 70s, so the hospital and the institutes out there, there was the idea of distributed nuclear power. So small nuclear power, relatively small, 100 megawatt instead of 1000 megawatt, close to the cities, because it was expected to be implicitly safe. It was a different process than the usual ones. And it was meant for cogeneration. Not only electricity but also heat. And in that case, the promise was cheap energy for free, both on the electrification and on the heat side. And one consequence was that they built a district heating network out there, unfortunately with very high temperature and pressure, which is, if energy is for free, it doesn't matter. If you have to pay for it, it matters a lot, because it's a very valuable and unfortunately also expensive type of energy if you have hot steam, which you don't need, because most of the heat applications are low temperature. And later on, when unfortunately or fortunately you may argue, when as a matter of fact this distributed nuclear idea didn't take off, so there was no cheap energy, and they had to serve it with traditional sources, they were heavily suffering from that and were always complaining about this relatively, from an energy efficiency point of view, relatively stupid network that they built, dreaming of free energy. And I'm pretty sure they still have reminders of that, because, as I said, adaptation in the public sector and buildings is not a strength. Well, then the next change in the perception of the priorities came in 1973 with the first, so-called first oil crisis. All of a sudden there was a disruptive change of oil prices, and as a consequence all other prices as well. I think the most important thing is that it was a disruptive step. If you would look at the prices that were said to be extremely higher these days, for today's knowledge, you would laugh. They were relatively low compared to where we have been in the meantime. But it was a step, and step change are usually shocking people and making them aware. It was a sharp step for the first time ever. Until that, oil was always perceived to be nearly as cheap as nuclear power. So the dream of free energy was everywhere. By the way, one of the consequences is that Aachen replaced its tram by diesel buses because diesel was so cheap. So you're still enjoying consequences of these days. And later on, people were quite sad about this decision because today they would prefer to have still the tram. But well, it's gone. There are some I think there's still one coach out there in a depot as a museum. You can say a reminder that Aachen once had a tram. So and then in 73 the dream was over. Energy wasn't cheap anymore, and that means all of a sudden energy efficiency was high on the agenda. For the first time, you may say, saving energy. And the consequence of that you still can see is, we are talking about long-lasting infrastructures, decisions made at one time last not forever, but very long. In the 70s, there was a strong political push, for instance in Germany, to build cogeneration and district heating networks in cities all over the place, and by the way also in Aachen we have a district heating system. There was strong political support for that, and you may remember that later on. I would say this political pressure resulted in district heating systems which not all of them were economically feasible. So some of them were a little bit more expensive than other sources, which wasn't the problem at that time because electricity was a monopoly. So if you were not able to compete on the heat side, because there you had always competition, people had always the choice to go for oil or for gas or for district heating. So if the district heating system wasn't competitive on that side, you could always solve it in the electrical side. So you could be competitive on the heat side and just increase the price for electricity. And the electricity customers had to pay the bill. Once the market was liberalized, unfortunately that wasn't possible anymore, and that resulted in a lot of problems for many of these district heating systems which were pushed for in the 70s and which were not ready for competition later on in the zeros of the new century. Around 1980 and from then on, I would say, political or societal acceptance became a bigger issue. You may say that's also a result of a sort of emancipation of people learning how democracy works, what freedom they have, what means they have. Definitely it was a learning process. And the first, you may say, victim of this discussion was nuclear power. So the same nuclear power that was perceived to be a solution to problems in the 50s and 60s all of a sudden was the biggest problem. And with some decades of delay, you may say the same happened then around 2003 and from then on with networks, where we also have a lot of acceptance issues today. While when I was a child in the early 70s and I lived in a village 130 kilometers east from here, a few hundred meters behind our house they were building a 400 kV overhead line. Well, I knew that it was an overhead line. I didn't know that it was a 400 kV one. Nobody knew because nobody cared. In the best case, people were quite happy that the future was somehow arriving in our village with electrification, where it was there before. Nobody cared. And it was really just between the houses. So there was the border of one village, and then there were 300-400 meters to the next village, and just in between there, they built the line. It's still there, by the way. But in the meantime, there are all houses over the place. So the gap between the villages has disappeared. Today, that would not be possible anymore. So political acceptance became an issue, and yet somehow you see I've colored this in green, which refers to sustainability. Sustainability is more than environmental. Sustainability says that you can do something in a way that you can continue to doing that without running out of any resource or other showstoppers. And of course, acceptance in the society is also a possible showstopper. If you take steps that will not be accepted in the long run, it's also not a sustainable approach. That's why I've indicated it, why I marked it green. In the 90s, all of a sudden, you may be surprised, for over a long time there was no blue anymore. Why not? Were people not sensitive with regard to economies in the post-war period? Certainly not. Of course, people were very sensitive in these days, but what also happened, what is not mentioned here, in this time power systems were growing. The market was growing, applications were growing, demand was growing, and at the same time also the size of the power stations primarily was increasing, and the whole industry was benefiting from the economies of scale in generation. So with the ever bigger power plants, electricity became cheaper, more or less as a windfall. Not because people were working more efficient or anything like that, just because technology became cheaper. But there is a saturation. Economies of scale doesn't work forever. And when unit size of around 1.3 gigawatt were reached, one unit, so generator plus turbine in the nuclear power plants, 1.2, 1.3 gigawatt, there were no further economies of scale. That's why we don't have bigger ones. It doesn't make sense. Specifically, they don't become cheaper anymore. So there was a saturation of this, you may say, windfall, cost reduction. But people were even more looking for cheaper electricity, and people in this case means in particular commercial and industrial users of electricity. Private people were pretty fine with their bill, but commercial industrial customers were raising this issue. Why in the 90s? Any idea why that became hot in the 90s and not particularly in the 90s? Well, the 90s were the decade in which something began, which we all have become used to, which is called globalization. So global competition increased dramatically, and industries were looking for opportunities to reduce their cost. And it's always nice to ask others to do the job. So if you buy electricity, it's easier to ask the electricity sector to become cheaper than to sort it out in your own factory. So it was all over the place in the industrialized countries, there was an expectation that energy should become cheaper. And that was the driver for liberalization. Liberalization as an idea evolved in the late 80s and it became a political concept in the 90s, and that's the reason. So it's directly linked to, first of all, the assumption this is a mature industry. It has somehow reached its final size. There was also no growth in demand anymore, so there was no need to ramp up the systems anymore. Networks were built, power plants were built, no additional investment needs, only maintenance. So the assumption was, well, this is a mature, well-established industry, no technical risks anymore, so now we can squeeze it out. It's all about efficiency. And we introduce in competition in order to ensure that the existing assets will be used as efficient as possible, which in principle is maybe not a bad idea. I'm stressing a little bit this, the environment because you may have recognized, if you follow such discussions, that there are more and more people challenging the concept of liberalization in today's situation. and also challenging the mechanisms within the liberalized systems. And one of the reasons is that we are not in a stable situation anymore. Because of the strong focus on decarbonization, the rapid growth of renewable energies, we are not in a situation where we can say, well, the system is built and we only have to run it efficiently. The system is subject of fundamental transformation with a lot of additional investment needs. So one of the fundamental assumptions of liberalization is just not given anymore. It's not an existing system that only needs to be operated efficiently. It's a system which is subject to a fundamental transformation. I do not want to say that a liberalized environment is not a good idea for that. But I want to stress that one of the fundamental assumptions from these days is not in place anymore. And it was also not the end of learnings. It was around 2000, latest in 2006, when the Stern report was published. I'm not sure whether you know the Stern report. It's already again 13. So Sir Nicholas Stern was, if I remember right, an advisor to the British government, and you may say he was a representative of the conservative world. So he was not blue-eyed running into any environmentalists' scenarios. He came more from the other side, from the normal business side, and he was the first one who said, well, it will cost us dramatically more to sort out the consequences of climate change than in investing in preventing it. And with that, it was all of a sudden in normal business. So, and in the normal political and business world, it was not something from the outside anymore. He was, you may say, an insider of the, you may say, old world. And that was a fundamental change in the discussion, because all of a sudden, somebody who enjoyed a very broad credibility raised the issue. So in the 2000s, carbon constraints became more and more, began dominating the political agenda all over the world. That was the time, I think, in fact, it began earlier, but in these days it became effective. I think another important milestone was the Kyoto Protocol, which, if I remember right, was in '92. So it always takes some time. But in the 2000s, it was in many countries so high on the agenda that it also showed consequences. And the most visible consequence, particularly here, were the renewables in electricity. And there we are. So from that on, the assumption of a stable, well-known system that simply needs to be only operated more efficiently was not applicable anymore. Well, I said, you may be surprised that we have not much blue in this line. There's also a long time that we didn't talk about reliability. And indeed, we really didn't talk about reliability, at least not in Europe. Because we were enjoying such a high level of reliability of supply that nobody cared. Why was it back in 2003? And why particularly in 2003? Do you remember what happened in 2003? It was an interesting year. Well, the first thing that happened was a big blackout, 1.5 week in the US, in northern US, New York, and a big area. And already at that time, some people started discussing whether that could be a consequence of liberalization. I should mention that when liberalization was introduced, many people were concerned that it would affect reliability of supply. If you look into the details of the US blackout, then you can easily conclude that it has not much to do with liberalization or unbundling, but it has to do a lot with bad engineering, very simply. There were misconfigured systems, there were flaws in information exchange, so it was really, it could easily have been avoided, let me say it like that. When it happened, it enjoyed, of course, a lot of attention all over the place. And I remember I was driving across the country listening to the radio news, and then somebody was asked whether this could happen in Europe. And they asked, I don't know, either it was a representative of a network operator or it was a representative of academia, a knowledgeable person, let me say it like that. And the knowledgeable person said, well, it will never happen in Europe. And then he gave some reasons which I found a little bit strange, but that's not the point. I used to say since 2003 I know the exact meaning of never. It's about 3 months. Because 3 months later we had a blackout in Italy, all over Italy. In difference to the US, the restoration took only 1.5 days, but it was a blackout, a countrywide blackout. And here you could clearly say there were some links to markets and liberalization, because what had happened is, the interesting thing is, it happened at a time, it happened during night. Italy traditionally is a net importer, so Italy doesn't, since ever, didn't have enough capacity to cover its peak load. And that was the first response. Now there you see what happens if you are not self-sufficient. But at night, even Italy is self-sufficient because the load is very low. So it happened at a low load time, and you may wonder why. And there you can say the very simple reason is because the markets, the price signals had resulted in a situation that despite being self-sufficient, Italy was still heavily importing during night, because it was cheaper to import from France than nuclear power from France than to produce it locally. Even worse, they even had all of their pumped storage at full speed pumping. Well, and then some lines in the Alps failed because of a weather incident. So that may happen, but they brought the system in a critical situation simply because of market signals. And well, you may argue that's the reason that's expected, that a market should look for efficient utilization of assets. But of course, you could define some limits, say, well, you shouldn't exaggerate. And you may discuss that this was a certain exaggeration. There were some more bigger disturbances in 2003. These were the two system-wide. There was a big failure in London, which was more a distribution network-related one. There were several incidents on distribution level in German cities. So I don't know why 2003. In fact, they had all different reasons. And there was one very severe incident in Sweden, which was a common mode failure of, I think, 2 substations, which normally is expected will never happen. And unfortunately, this failure resulted in disconnecting a nuclear power plant from the grid. So the nuclear power plant was isolated. In a situation when a nuclear power plant is isolated, it has to supply itself. So the auxiliary generators have to supply the plant in order to ensure cooling. Unfortunately, none of the auxiliary generators started. So it was a very, very critical situation in Europe. And at the last minute, one of them started, in fact, fortunately. It was a very critical. So 2003 was a wake-up call. And it brought reliability of supply back on the agenda, and it brought particularly the need to look at networks on the agenda, because nobody looked at networks before. If you had tried we tried, of course, as networks, as suppliers, we tried to make people aware that if with all the changes, it may make sense to do some research on networks, whether they are sufficient, whether we may need new technologies. And if you try to raise that anywhere, people looked at you and said, why? They do work. It's all developed. Why should we spend anything on networks? It changed dramatically after 2003. Today, networks are everywhere. If you want to get public research funding, you just need to say, I want to do something on networks, and you will not have, I promise you will not have a problem. But there was a time when that was totally different, and that was before 2003. 2006, again, I mentioned the Stern report already. Energy efficiency and climate protection were on the agenda, both because of climate change, but also because at that time we had very high energy prices. I remember that we did an internal study trying to figure out what, with a 10-year horizon, we should be prepared for, what networks might look like in 2015. It was called Power 2015. It was built on very basic macroeconomic scenarios. And they were very different. They were reaching from a totally open, highly competitive world economy to, on the one extreme, and the other extreme was falling back into national protectionism. And there were some in between. So we really tried to cover whatever was possible. And there was only one thing common in all of these scenarios, and that was energy will become more expensive. And in 2005, when we were run this study, there was still a common pattern of thinking in industry that high energy prices are bad. So you can imagine when we came to that point, when all of the scenarios indicated energy will become more expensive, we were a little bit depressed. By the way, the reason why we said that was because primarily it was the oil price, and the reason why we expected this to happen was that we came from at least one, maybe even 2 decades of relatively low oil prices and underinvestment in the upstream infrastructure. So it was not about availability of primary energy. There is enough oil, at least. It was because there had been underinvestment in refineries and all what you need to process it. And if the infrastructure is underinvested, you can't change that from one to the other day, which is, by the way, a learning that we will see in electricity. So if you know that you don't have enough infrastructure at a certain time, then you can't expect that to be fixed in a short period of time. And on the other side, demand was, of course, permanently increasing. I would even not call it slowly, simply because of the growth of population. So it was not a difficult equation. So you have growth on one side and insufficient infrastructure on the other side. You can detect as much as you want, you will not be able to get it out of the ground. So that's why we assumed energy prices have to increase. And we were depressed, and then we started to think a little bit, and then we were not that depressed anymore, because as a technology provider we said, well, high energy prices are not bad, because if energy prices are high, people will care about energy efficiency. They will spend more money on more sophisticated solutions, and we are selling the sophisticated solution and not the cheap energy. So why should we be depressed? And you may say that is applicable more or less for most of the countries, because there are not so many countries with a business model built on natural resources. The majority is built more on industry and good solutions. So we thought, well, maybe we need to change our approach. And at that time, just to make you aware what we were talking about, we expected an oil price of $150 per barrel to be extremely high. Today, we would agree, because at the moment I think we are at 70 and talk about high prices. So at that time we were at 150, and 1 year later we were at 200, nearly at 200. And did the economy stop? In 2006, no. 2006 was the beginning of the boom that we're enjoying until today. So we learned our lessons. It was not as simple as we thought. But since then, energy efficiency and climate protection were on the agenda. So you see already over this time a lot of changes. But you also see this slide ends at 2006, and we are in the meantime in 2019. So didn't anything happen afterwards? Of course not. What happened now? That was not the plan. Let me check. There is a continuation. But what you also see is, sorry for that, the dynamics have increased, and that continued since then. So the priorities changed faster. Is that because we don't know that much about these days? No, I think it's simply, I think it has to do with information exchange, with availability of information. Priorities are man-made. It's human perception. So these priorities is what is on the political agenda. It's not a natural law. So and the faster you can activate people, the faster priorities will change. So that is what we see. And we also see, of course, a lot of learnings in these days. And liberalization, by the way, is one contributor to forcing us to learn. Because you may say liberalization as it began in the 90s is a big experiment, reorganizing a key industry. And there was no blueprint for that. So it's still an ongoing learning experience with mistakes, with new findings, with new surprises. The fact that you need to look at grids, for instance, was one of the surprises. And you may say it's not very surprising, but well, people were so much busy with the generation and energy part of the business that they simply didn't look at networks. So, and that's still not at its end. So there are various reasons why it has become more dynamic. But that also explains why this industry has become more challenging. You may also say more interesting. You want to be challenged, I guess, young people. So it definitely has become a more interesting place. So let us shortly go through the same period of time, a little bit more in practical. What did it mean in Germany? I will try to avoid repetition. Because what you saw so far were the perceived priorities, and now it's a question, what did it result in? I mentioned some examples, but not all. So before 35, and by the way, interesting enough, this applies both to Germany and also to the US. I don't know why they all did the same step in the same year. Definitely not because of close alignment in these days. So before 35, electrification was, you might say, growing bottom up. There were local communities, there were industrial visionary people building up companies, so there were different, so electricity systems were growing in an uncoordinated way, driven by individual initiatives. I think we have both. We have municipal being active in this area. In the early days, we had local networks, a truly distributed supply. They were not connected, but we also had industrial players investing. And so I have one in mind, Oskar von Miller, an Austrian. They were building, for instance, in Bavaria. At that time, I think it was one of the biggest hydropower plants in the world. It's still in operation. It's a storage power plant, the Walchensee Kraftwerk. It's about 125 megawatt. It's not small. At that time, it was significantly bigger than the demand in entire Bavaria. So you need to imagine, people were building something which was definitely more than the entire market, one single plant, because they believed in the growth. So it was such type of people driving this development. And in 35, the state intervened, and as I said, surprisingly, it's a very similar structure both in Germany and in the US. They introduced private ownership, so it was not a state-owned industry, granted local monopolies, but by granting local monopolies, they were also subject to state supervision. So they were private, but they were not allowed to do what they wanted. They had their area, they had to apply for an area, which is, by the way, still the case for networks, the so-called concessions. It's a contract between the local authorities and the private company, allowing the company to operate an infrastructure on behalf of the society in a particular region. But in these days, this was including generation, so that you had a monopoly supplier. The place where you were living was defining from where you got the electricity. But the price the companies had to pay for that was that they were state-controlled, price control. And why did the state do that? Well, one side, of course, one result of that is that you can ensure that everybody gets supplied, because you can offer that to companies everywhere, and you can also make sure that it is economically attractive enough that people invest, even in structurally weaker regions, because then you accept simply higher prices, or you do something. So this, on one side you can ensure the service. On the other side, of course, you can also avoid that individual companies become too powerful, and that was a strong motivation to do that. That I think policymakers had understood how important electricity is, and they wanted to avoid that individual companies without any control become too powerful. That was a strong motivation behind this step. And you may now wonder, why the hell no policymaker recognized that in today's information market? Because there we don't have such a step. We have accepted, without having been asked, the growth of global monopolies, which are totally uncontrolled. So that was a different approach. And I think one of the reasons maybe that it's easier to understand what energy means to people. Energy per se was not new, electricity was new, but that energy is important was clear. Energy is always, since the Industrial Revolution, it's clear that energy is the core of a core element of the way of living that we are used to. Before, it was not that important, but well, heating, at least in this part of the world, was always important, but the dependency of people from energy has dramatically increased with the Industrial Revolution. Well, at that time it was coal, but it was clear that energy matters. Maybe it was clearer that energy matters than to today's policymakers how information matters. From the 30s, and why, by the way, just one comment, why is the second column called limited resource? You may remember that in the last lecture I stressed a little bit that in an economy, people trying to focus on the limited resources. What people perceive to be limited defines what they care about. And that's not necessarily money. Money is only, you may say, a common language in which you can translate everything. But the real driver is maybe something different. And the limited resources in this period between 35 until the 80s was still technology. So in that time, they were still heavily focusing on expanding the limits of technology, making power plants bigger, making voltage levels higher. At that time, power technologies were still high-tech. Front-end technology, which later on was hard to imagine, and now we're coming back with the new challenges, but it's a different type of challenge, of course. So in these days, these monopolies, they were also very technology dominated in their mindset. If you talked to utilities in these days, they didn't talk much about economies. Well, okay, they had their monopoly, money was coming somehow from the people. They did a good service, so they didn't take, at least not by intention, too much money from people. Maybe a little bit because of internal inefficiency, but not by intention. They were not earning much money. So the income of the monopolists was not very high. So that the EBIT, maybe the turnover was higher than needed. So they got more money from the customers, but they also spent it. They spent a lot. They were not looking for extraordinary earnings. That's what today's companies do in competition, and but they were primarily thinking and working on making the system more reliable, bringing new technologies in, trying new things. So that was the limited resource. And then at some time, everything, you may say everything was invented. It became, technologically, it became a little bit boring. So when I decided to join ABB in 1994, my colleagues, particularly switchgear and substations, my colleagues here asked me, why do you go there? There couldn't be anything more boring. Well, it wasn't boring, I can tell you, but not because of the circuit breakers, I have also to admit. In the 80s, 90s, environment became the biggest issue. There were the decisions in Germany to close down nuclear power stations. Initial support programs for renewable energy were launched, which later on resulted in today's Renewable Energy Act. And efficiency utilization became an increasing issue. And then in the 90s, I mentioned that before, price acceptance, at least in the industry, among industrial customers, became an issue, and that resulted in liberalization. And there we are, and now let's talk a little bit more about liberalization. So what is the initial idea? If you look at a vertically integrated monopoly electricity system, then you can say it combines the entire value chain. That's why it's called vertically integrated. So it integrates production, in electricity we call it generation, and logistics, the networks. But that's not typical for industries. Normally we have split these parts of the value chain. Normally you have factories somewhere, you have a logistics sector which is shared by many industries. Normally part of the logistics sector are the infrastructures like streets, railway, ships, airplanes. There are companies using these infrastructures, offering different types of services. There are other companies organizing sales of goods. Normally this is not necessarily the factory owner. It may be, but this is more the exception than the rule. Normally you have wholesalers in between, you have trading organizations specialized on what they do. None of that was the case in electricity before liberalization. And so one of the basic ideas was, why should we treat that industry so much different from what we're used to? And what, from a customer point of view, I would say normally is a pretty successful approach. So competition creates, normally is expected to result in efficiency, but also it triggers also creativity. So we get new products, we get a lot of different offerings. So why not in electricity? And that resulted in the first fundamental step, which was then let's separate the production sector from the logistics sector. And technically that means let's separate the networks from generation and treat them differently. On one side we have the product that we want to buy, which is energy. Physically it's the energy in time. Maybe we should add in time. You may have heard about, there's a permanent discussion whether the energy, so-called energy-only market is the right approach for a system with a high share of renewables. Maybe you've heard about this question. And energy-only market suggests that this market design doesn't care about the time of delivery, which is not true. And you will hopefully see that later on. So if you ever hear energy-only and somebody suggests that does not reflect the availability in time, well, it's not true, it does. So the product is energy in time. So you expect that you get energy when you need it. That's why you sign a supply contract. You don't sign a supply contract in order to achieve that your annual consumption is produced at some time independent from your needs. That's not what you sign. You expect it to be delivered when you need it. And the other part is the service market, which is transmitting and distributing energy. The service market, or the service part, maybe we should better call it the service sector, has some characteristics. The first one is, and you hopefully remember the last lecture, it's fixed cost dominated. It's more or less only fixed cost, and it's very high efforts for the infrastructure compared to other energy sectors like gas or oil. The share of the networks in the total cost of an electricity system is much, much higher. It's nearly 50% of the overall investments, whereas, for instance, in gas, the network has only, I think it's less than 10%. So electricity network are an expensive infrastructure. The fact that they are representing only fixed cost is one important reason why they can be considered as a so-called natural monopoly. There is an important other reason. We'll see that on the next slide. But what you can conclude here already, introducing competition in networks would be very disadvantageous from a macroeconomic point of view. And if you don't understand that already now, you will immediately understand why this is the case. On the other side, the product energy, power plants can compete. They represent more or less a normal industry. So they have variable cost, they have fixed cost. A normal, I have to say, commodity industry. What does commodity mean? Well, commodity means they're all producing the same. Physically, they're all producing the same energy. It's standardized because of the, well, first of all, because they're all feeding in the same network, but also because you expect always the same if you connect the device to the network. To the network. So physically, there is no differentiation possible. And it also cannot be separated. So if you sign a contract through a supplier with a certain power plant, you cannot be sure, or it's even more extreme, you can be pretty sure that the electricity that you consume will not come from that power plant. It will come from any, following the physical laws. Nevertheless, your contract has an impact, and we will see that later. What does this mean? It means that it's very it is not possible to compete or to differentiate based on the characteristics of the physical product. You always expect energy and time, not more and not less. There are scenarios in which you could imagine more. So just as an example, if we all had so-called smart meters, remote controllable, then it would be possible to differentiate, for instance, on reliability of supply. Because you could sign a contract allowing your supplier to disconnect you earlier than others in case there is a congestion. That would be a differentiation. So you would offer some flexibility and you would expect a lower price for that, of course. But with today's infrastructure, this is not possible. Not yet, because we don't have smart meters everywhere. And we also, I'm not aware of any market where we have such contracts, at least not on residential level. Industrial customers have such differentiation. They're your big, large industrial customers. There you can find such things. But today, this is still not possible, so the reliability of supply that you enjoy is not defined by your needs, but it's defined by the street in which you're living, by the feeder to which you are connected, the network structure. It's not part of your contract. So the product itself is not, you cannot differentiate it. What you can do, of course, is you can differentiate contract clauses. For instance, you can be asked to sign a long-term contract, and that gives certainty to your supplier, so he could offer you a better price for that. If you commit for several years, for the supplier, it means he doesn't need to spend that much sales effort, so he saves money. Certainty also means money, so he can do that, but not on the physical side. I'm elaborating a little bit on that to make you aware a product in such a market is not only the physical part. A product is the combination of what you get and the contract that you sign. And differentiation in the contract is possible, and we'll see that later. But on the other side, it means the strongest argument to differentiate in such a market where you cannot differentiate on the product is what? It's a price. So in a market where you can't differentiate by offering something different, you will always have to differentiate by the price. So there's a strong fundamental logic that competition in electricity is primarily on the price. And again, I'm stressing that a little bit because that you may say that's always the case. No. In a normal market, in a non-commodity market, you would always try, if you're a little bit clever, you would always try to escape from price competition by offering something different. I once heard from a marketing professional an interesting sentence which brings that at a point, saying, the best competition is the one that you avoid. So offer something slightly different, something that your competitor cannot offer. Not all of the customers will like it, but you also don't need to have 100% market share. You only need to find enough people that love what you offer and that you can run your business from that. And if you have something that your particular target group likes and no one else offers, then the likelihood that your particular target group will pay a little bit more is pretty high. And then everybody is fine. By the way, that was over a long period of time. It's called a niche strategy, the Apple strategy. Apple never wanted to compete with Microsoft. They had their niche, which was much more willing to pay, much more profitable, but smaller. And you couldn't exchange the products. Although in the end it's the same, it's a computer, in the early days, before the smartphone. So let's talk about the natural monopoly, the networks. First of all, from a competitive point of view, the theoretical background is competition is strongly influenced normally by marginal cost, as long as you have such. Because the marginal costs are directly linked to the product you offer. Why are the marginal costs so important? Well, imagine you are in a very competitive situation. You're running a factory. There's overcapacity on the market, so there's more products on the market than buyers. And you definitely want to get the order. You want to fill your factory. What is the lowest price that you will offer? How far do you go? Sorry? To the marginal cost. And why? Well, exactly. If you get a little bit more, so you will. If you get a little bit more, well, of course you don't go to exactly the marginal cost, because then it's just turning around money. But if you get close to it, you then get at least a little bit contribution margin for your fixed cost. So that's what normally defines. That's the reason why marginal costs are defining. And in the end, it's assuming we have the same product, no differentiation, then normally vendors will be used by the market up to the highest marginal cost that you just need. And that's, by the way, the pricing mechanism that we will see in spot markets for electricity. So you imagine from buyer's point of view, so the cheapest vendor will most likely be not sufficient to serve the entire market, so you need a next one, and you need one more. But at some time you don't need more. So that the highest variable cost that you just need to serve the market is setting the price. So that's why variable costs are very important. Well, we said in networks there are no variable costs, so it's difficult to use that pricing mechanism. By the way, be aware there are markets, competitive markets, with fixed cost only or high shares of fixed. So it's not impossible. You will have different pricing mechanisms. You will look more for long-term contracts to ensure that you're finding, but it's not impossible. It's more difficult. It's also, I would call, uncomfortable markets, but it's not impossible. But there is something more. So now let us look at what happens if you lose a customer. From a company's point of view, what would you normally do? In a normal competitive business with both variable and fixed cost, the first thing that will happen is you will reduce your production. You always can do that. And that means you immediately reduce your variable cost. So you may say you reduce the pain a little bit, at least. It's better than nothing. And by the way, if you haven't heard about it before, if you will work in industry, you will find that industries normally try to make as many of the cost variable as possible. And that's exactly the reason. If you have in the extreme case, if you have only variable cost, then it doesn't matter if you lose a customer. Why did I say transform into? It sounds as if you have a degree of freedom, and yes, you have. Because costs are not by nature fixed or variable. It's always a matter of your standpoint. If you look, for instance, at if you look at a gas supply, then normally you can perceive gas, and we have seen that fuel as from a power station's point of view, as a variable cost. It's not exactly true, because the contracts normally have a fixed part, but the majority is variable. And you may close if the gas seller is agreeing to a 100% volumetric price, then it's variable from your point of view. But the cost structure in gas is, of course, not 100% variable. You have huge infrastructure cost. You have the networks. So from the gas supplier's point of view, it's not 100% variable, but he takes the risk of transforming that, and from a power plant operator's point of view, it may be variable. And the same applies in many other areas. If just an example, which is somewhere in between, it's not direct production related, but it's also flexible or not flexible. You can decide to build and own a building, your factory. And then it's obviously 100% fixed cost. But you can also lease it from someone else and have a flexibility clause. And then it's adjustable, it's flexible. It's still the same building, but from your point of view, it's more flexible. You will not change it from one to the other day, but maybe from one to the other quarter or year. It's definitely more flexible than owning it for 30 years. Do you get that flexibility for free? Normally not. If, then your business partner would be stupid. Of course, you have to pay for that flexibility. He will ask you a premium for that service. It's a service, but it gives you more flexibility. And if you look in industries, you will see they will always try to make as much flexible and adjustable as possible. And that's the reason. This exactly, and nothing else. Be prepared that your business decreases. And don't sit on too many under-absorbed fixed costs then. The second step that you can do is you can try to, well, you still have a reduced coverage of fixed cost. But what you usually can do is you can look for new customers to get loading back, because the idea of a factory is normally that you are not linked to a particular customer. So you can reuse the capacity, that production capacity that has been released by losing a customer, by finding new customers. So that's what you normally do in a competitive business. Now let's run through the same discussion for a network business. So first is, there is no reduction of variable cost, because there are no variable cost. It's still the same network. Of course, you have reduced coverage of fixed cost, so the pain is the same, is even higher because it's 100% fixed cost. And at least in the distribution networks, there is no chance to reuse the asset. The line that has been built to a particular customer cannot be used for another customer. So if we had, as a model of thought, parallel networks, you would always have a high degree of not underutilized, not utilized lines, which is, from a macroeconomic point of view, obviously very inefficient. So there is a significant share of the investment which is customer specific and irreversible. And if you just remember the figures that we saw last time, the distribution of cost on the different voltage levels, then you may remember that the low voltage networks, which are definitely in that category, are representing more than half of the total cost of the network. So we are not talking about a marginal problem. We are talking about the biggest position in networks. And that's the reason why at least distribution networks are definitely natural monopolies. In transmission, you may argue it's a little bit different, because you have mesh networks, you have some overcapacity, you have some flexibility, and there's not that black and white. We have cases where we have at least some type of competition in transmission networks. It also is not very beneficial, but it's not impossible. But on distribution level, it definitely doesn't make sense. And that's why we have natural monopolies in networks. And if you want to introduce any competition in power systems, We have to separate the networks from the rest because we can introduce competition only in the rest of the system. So I think I introduced this concept of some background information last time already, so whenever you see such a gray slide, it's a little bit more theoretical background here on natural monopolies in general. They are not limited to electrical networks. So that was an introduction on the motivation for liberalization and well, a very fundamental underlying principle. And now let us look at what questions need to be answered if you want to liberalize. And when I'm saying liberalization process here, this implies that you introduce liberalization always in existing systems, which means they're all coming from a monopoly system, and that's indeed the case. So in the early days, all systems all over the world were integrated monopolies, and that was, on one side, I mentioned already, it was an opportunity to ensure that this service was rolled out to everyone, because you could do that with pretty much state influence. It should also be mentioned that the other reason is that people indeed could not imagine to run such a system, which is still a technically integrated system. We may talk as much as we want about unbundling. Unbundling is only an economic separation of players, but the system is of course technically not unbundled. It's still one technical system. And if we look at Europe, which I think is the most, well, geographically I think the Russian system is even bigger, but with regard to inhabitants, load, countries connected, the European is definitely the biggest and most complex in the world. Well, it spans from the Baltic states down to Portugal and from Great Britain down to Turkey in the meantime, and even with some expansion. It's one physical system. Each component is connected to each via copper in this system and some transformers, so there are some galvanic separations, but it's one technical system. And people could not imagine that you can run such a system with separated economic responsibilities, following other priorities. If you have different players in the same system, some owning and investing in power plants, others in networks, they do not necessarily have the same objective. If they wake up in the morning, they do not necessarily think, what do I have to do to keep the system stable? Some of them may think, what do I have to do in order to earn as much money as possible? And there have been such examples, extreme examples in the meantime. So there were concerns that it's not possible to run this industry without integration. And when the concept of liberalization was under discussion in the 90s in Europe, I remember one of the senior managers, well, the most senior manager of one of the big German utilities was publicly, scientifically arguing that it is impossible. It was not good for his career, and obviously he was not right, as we know today. But you should be aware that was the type of... So we all the systems that are liberalized and unbundled today come from an integrated past, and that means you have to think about how far do you want to go, what do you want to do, and also what do you have to do during the transition period. So the first question is, who may sell what to whom? You may say, who to whom you may understand, but what? Didn't I say before it's all about energy? Yeah, but you will see there are a number of other products in the market and services that are also required to keep the system stable and to run it. So it's not only the... Energy is definitely the central product of the market, but it's not the only one. And then the next question is, to what extent is competition necessary and reasonable? Maybe that sounds also surprising to you, because if you talk about liberalization, you may say, well then we have competition everywhere. Oh no, there are some steps in between, and Hopefully you remember that well, I don't think I stressed it that much last time, so maybe you can't remember, but I stress it now. If you introduce competitive elements in a market, then you should make yourself aware before what's the real issue. What do you want to achieve? It's not always the same. It depends on the stage of development of, well, in that case, the country. You remember that I said the strong driver for competition in the 90s in the industrialized countries was that the industry wanted to get cheaper electricity, assuming that there was no growth anymore. There was no growth in the 90s, at least not much, in the industrialized countries. So it was a desperate, competitive market on well, getting more out of the same market. It's not fun, I can tell you. But there's still a lot of countries, and I would say industrialized countries, you hopefully remember that not all of the countries in the world, in the 90s I would say, even still a minority, was called industrialized. There was another big group called the emerging countries, and there's still a big group called the emerging countries. An emerging country has a totally different situation. Emerging implies already there's a lot of growth. Otherwise they wouldn't emerge. So it's much more dynamic. And if an economy is growing anyhow, maybe cheapest electricity is not what they need. Maybe they need investments in additional power plants. In order to attract capital to invest, maybe a super competitive market with lowest margins in the end product is not so attractive. So if you want to attract investors, maybe you should think about another approach. So it always depends on what you want to achieve, and it's also not stable. Well, countries are developing over time, systems are developing over time, so there may be different answers to the question over time. And we will see examples for that, because there is not one model only. You need to think about, if you want to open the market, what type of contracts you allow on the wholesale market and for contracts among market players. I would say there are markets which were originally at least 100% handled through central institutions, through central markets, spot markets, and no bilateral trading. So there was no chance to close a direct contact between two players in the market. It all had to go through a central market. We will see these examples later. And there are other markets where the majority of the business is done outside the central platforms, bilaterally between market players, and only the remaining smaller part is handled through the central platforms. I'm not aware of any without a central platform, but and both has pros and cons. And controlling and pricing of the grid is a very important issue. We will see that because, we'll see that later. Ownership, always, of course, an extremely sensitive discussion, keeping in mind that we assume that we always come from an integrated past where generation and networks were owned by the same companies. So if you want to unbundle, you have to split existing companies, which is already a big step. But you may even go further and say it's not advantageous if both parts of the business are owned by the same owners, and then it becomes even more sensitive. But there are reasons to discuss that, you will see later. And then, as I said, if you change a system, you have always a transition phase. And if we accept that the basic assumption of competition and liberalization is that systems become more efficient, otherwise we don't need to do it. This also implies that we assume they have not been 100% efficient before. Otherwise, we would not need to take that step. So there is an underlying assumption that there are inefficiencies in the system, which we want to eliminate. Otherwise, this whole exercise is not necessary. But that means, to make it practical, in a transition period, these inefficiencies have to be removed. And these inefficiencies may be stranded assets. And I brought the example before of cogeneration systems in Germany in relatively small cities with relatively small and economically not super efficient plants. If you open a market, then all of a sudden they're all running out of money. What do you do with them? You shut them down? Well, the people depending on the heat from them will not be very grateful, because if they're out of business, it will become pretty cold. And consumers cannot immediately respond to that. Your flexibility is limited. If you have a house with a district heating system and all of a sudden you don't get heat anymore, well, you could argue you can replace your heating system by an oil boiler and a tank maybe. Maybe you don't have a room for a tank in your building. So there are some inflexibilities. And by the way, it's also an investment issue, of course. Not everybody is prepared to take such investment. So in a transition period, such things may happen or need to be handled. You may say, well, it's obvious. You're sitting at the moment in a country which didn't do anything about transition in the beginning. They assumed the market will sort out everything. It did not. It became quite painful, and then a lot of corrections needed to be done. Other countries thought about that proactively. There's quite a big variety. So, who can sell what to whom? The first question. If we try to structure that question a little bit, then we can differentiate 4 different, well, I call it market models, although the first one obviously is not a market model. So let us say basic models of competition with a degree from zero competition on the left side and most possible competition on the right side, and some steps in between. What you see here is where we find competition, whether we have choice for different players, distributors, meaning distributors are companies selling to the end consumers. So they may be allowed to choose from generators, but they may still be granted a local monopoly against their end consumers. And this is, for instance, the setup here. Then we have the choice for end consumers. I don't want to discuss this all with this table now, because we have for each of them, for each of the 4 models, separate slides afterwards, and if I discuss it here, it will be a lot of repetition. What we see is the black boxes are the non-competitive, the monopoly roles, and you see, well, here it's all monopoly, and the share of monopoly roles is permanently decreasing to the right side. What I would like to make you aware of as a summary before entering the detailed discussion is this last bar. So the more left you go, the more investments are secured. The bigger the certainty for investors is, the lower the risk is. The more right you go, the more competitive the system becomes, which means the more risky from an investment point of view also. But also the more complex the system becomes. And well, you see the complexity here, where everyone can close contracts with everyone. What you also see is that here the market roles are, they're called generation, transmission, distribution, so they're obviously, the names are strongly determined by the physical infrastructure. And that's also how these companies behaved. Whereas on the most right side, you see generators still, okay, obviously power plants are a particular area, but all the rest is not at all linked to the physical infrastructure. You have a totally independent commercial market, which is, we're talking about wholesalers here, we're talking about retailers, that has nothing to do with the grid. Of course, there is a grid in parallel, which is not shown here, but it's of course assumed to be there, and you will see that later when we talk about the market model in general. So here we have much more commercial roles, much more contractual discussions than on the left side. A good question. The question is, is this efficient? And Well, on the slide on this retail competition model, it's mentioned as a question as well. I'm not aware of a real answer to that. I have doubts. I must say, I have doubt that residential competition with customers like us, who are basically depending on the infrastructure, which is not part of the competition. If you look at your bill, more than half of the bill is infrastructure cost. Well, and then depending on the country you are, but I think somehow everywhere. Another big part is taxes and levies, which is also not subject to competition. And then there is a small tiny part, energy, which is subject to competition. And within that, you have maybe a variation of maybe 10%, if it's already much, that you can really vary by changing your supplier. And for all that, you connect, in Germany, 40 million end consumers, case by case, to an industry. I have strong doubts that this is very efficient. And that is the reason why this third column is there, where the only difference between this and this is that we don't have residential customer competition here. And we have even seen markets which went for retail competition and withdraw from that after some time and limited it to only bigger customers. So I would say it's still an open question. And of course, the answer depends strongly on the IT infrastructure. If you may raise the same question for mobile telecommunication, where the monthly bill is even smaller, and nevertheless it works. But if you compare, change of supplier, they wouldn't call it change of, they even wouldn't call it change of provider. They call it subscription. In mobile telecommunication, where you buy your SIM card and then you go home, put it in your device, do a short registration, and then it's done. It's completely done. And by the way, there is even a safety check behind, which is not the case in electricity because of anti-terror laws. So they have to check your identity. So it's even more challenging. And nevertheless, they do that within 20 minutes, and I guess 18 of the 20 minutes are because you have to go home from your shop to your flat, and not because the provider needs it. That would be even faster. And if you compare that with a change of supplier in electricity, where they are proud to manage it within a month, you see some room for efficiency gains. So I would not exclude it if the right IT infrastructure is in place, but I'm not aware of any country in the world where the right infrastructure is in place today. Electricity business is still not an IT business. I've been in such discussion with people from the telecom industry, telecom providers industry, who explain me how they would change it, and then it becomes much more efficient. It's not rocket science. Well, it's not there today. So today, I think the answer is clearly no, it doesn't pay off. So let us talk about the four models a little bit more in detail. So I've referred to the monopoly already several times, why it was there. It granted the certainty, the stability, the economic stability to build up all these infrastructures that we are enjoying today. That's important. We introduced liberalization when all the investments had been done. And although liberalization in the meantime is, well, a quarter of a century liberalization, none of these markets so far has proven, none, that it is able to incentivize reasonable reinvestments. So investments is still the weak point, particularly infrastructure investments. So they all benefited from that. All these investments had been done in the monopoly time. By the way, I don't want to say that it's impossible, but we still haven't found the right rules to incentivize sufficient. And then there's one fundamental open question. You may have heard about it, it's permanently coming up, and there is a reason why it's coming up now, about a discussion whether we need capacity mechanisms or not. Maybe you've heard about that. Capacity mechanisms is another word for how do we get enough peak capacity. You wouldn't talk about capacity mechanisms for baseload power plants. So it's only about peak. It's about those power plants which expect an utilization per year of several hundred hours, which is not a very appealing business case. In no other industry you would build a factory for that. The normal response would be, in these few hundred hours, well, please wait. Shift demand, you would call it shift demand in electricity to a more suitable time. No industry will ever build capacity for peak demand. But we expect that from an electricity system because we don't have flexibility in demand. We have been educated like that. There were also technical reasons. It's difficult to buffer electricity, but we also didn't spend much intelligence on demand response mechanisms in the past. It was comfortable, we could afford it. No one is killed by his electricity bill. And it has all been grown in the monopoly situation. And there's no problem to build peak capacity in a monopoly system. You just build it and let your customer pay. He hasn't a choice. So that's, and we were starting from that. We were starting with systems with peak capacity. But over the years, you may say more over the decades, load grew, some power plants went out of operation because of aging, so all of a sudden there was no peak capacity anymore. And then reinvestment signals didn't work. And so far there is not one single market. You may argue there are also a lot of electricity markets where policymakers were not really confident in this new great thing they created, so they all introduced some caps that the voters didn't see too high electricity prices. So there are a lot of implicit or explicit caps. In Germany, for instance, what do I mean by implicit caps? In Germany, we don't have a cap. But we have the assumption that if the spot market exceeds the variable cost of the last power plant, then we have the assumption that this is a subject for investigation by the cartel authority. Well, it's not a cap, but you will not go above because you don't want to have such investigation. There are other markets, California, for instance, around 2001, you may have heard there was a big crisis, a lot of brownouts. If you look in detail, and in the last chapter of my lessons, there's an explanation what happened. They had explicit caps. So they had limited the retail price and also the wholesale price. It was not allowed to exceed a certain level. Well, in such situation, you don't need to be surprised that there will be no investments in peak capacity. Because peak capacity needs to be justified by scarcity prices. A few hours with very high prices, that's the theory. And if you don't allow these high prices, well, why should anyone expect? But there are a few markets which were really open. Texas, for instance, did that. There was no limitation. They had scarcity prices, but they also didn't get peak capacity because it's so short and the primary fuel prices are so volatile. So it's a super risky business, very speculative, and you don't find investors. So it's still an unsolved problem. And my personal opinion is, well, you either go for capacity mechanisms, which then again is a sort of state planning, more or less, or you think about demand response. You solve it on the demand side. You will not solve it on the supply side. It's just, it doesn't work. And by the way, the discussion in Europe came up with the renewables. And that was mixed somehow, because people said that's because of the renewables, because of the volatility. No. Well, the renewables made it more visible, because they made the peak even less attractive. But the problem is all over the place in all liberalized markets. It's not specific to markets with volatile renewables. So all of that was no problem in the monopoly world, and we ended with, at least here, with nicely built systems, very reliable, reasonably efficient, and there are some more advantages. In such a system, and I touched that already before, in a monopoly system, a state-granted monopoly, I have to say, not a monopoly like we are enjoying it with the IT giants, which is totally uncontrolled. A granted monopoly, here we are talking about state-granted monopoly, you may say is a sort of contract between the monopolist and the society. And the price, one of the elements the companies had to price was an obligation to serve everyone. So they had to connect everyone. And you can see that, by the way, also if you follow the current, it's quite intensive in the meantime, discussion in Germany on infrastructures. We're used that everyone has electricity. We're also used to that everyone has a landline for telephone. And there is an obligation to do that. So even on the last village, you have to connect. There's nothing like that for mobile telecommunication. And you know the result. Germany is on the wrong side of the spectrum with coverage of mobile telecommunications. So we are pretty weak. We missed it somehow. It's a little bit surprising for me still in a country which used to be very infrastructure minded that we missed that repeatedly in mobile telecommunication. But in a monopoly you can simply tell the provider you have to do that. And this called, by the way, this played also an important role in the liberalization discussion, primarily from France, who insisted in this so-called service public that they have to have a room where they make sure that people who under competitive considerations would not be supplied are nevertheless supplied. You can do more. You can give privilege to domestic energy resources even if they are not competitive as part of your energy policies and more. Just be aware in a competitive, you can decide that you want to go for cogeneration for efficiency reasons even if it is more costly. And well, if I say it like that, even if it is more costly, you may say, how stupid? Well, policymakers. There may be good reasons for that, because it may mean that you're more independent with regard from energy from abroad. If you with cogeneration, for instance, coal-fired, it's not very popular today, but in the 70s people did not yet care. If you could replace coal-fired heat with cogeneration, you had an opportunity to use domestic coal, clean. For the people it was clean, because you pushed the pollution outside the cities, and replace by that oil, which you have to import from questionable regions in the world, politically. That may be a value. It may make sense. So you want to be more independent from such unstable regions, so you do that. So there may be reasons for that. It's not only about the price of the end product. And all that is relatively easy. By the way, also environmental protection. You can just tell them you have to do that. Full stop. Well, it becomes more costly, okay? The end consumer pays. He cannot escape. It's a monopoly. The main characteristics are no one could choose his supplier. It's not only about no consumer can choose his supplier. Also no power generator could choose his network. No one had any choice. The full, you may say, the entire system of contractual relations was defined by the place where someone was. So very simple. In a pure monopoly, there are also no independent power producers. I would like to draw your attention to the last bullet point, may still be reasonable for developing countries. Why? Well, the entire idea of treating a power industry as a normal industry means it's an attractive industry to earn money. But in a developing country, maybe you have a completely different priority. You may say it's not important that this industry earns money, but it needs to be there to enable others to earn money. In the early days if you start an industrialization, you need electricity as a facilitator and not as a standalone business. It may be a very poor business, no demand, huge infrastructure investments. So if an investor has the choice to go there or in an emergent, rapidly growing market where you get immediate payback, where will he go? He will not go in a developing country. So you need to make it attractive, because electrification is a starting point. Without electrification, today you can say no participation in anything. Without electricity, you don't have anything. No clean water, no refrigeration, no cooling for food, no health, no information, nothing. So electricity is in the beginning of everything, but it may not be a business in the beginning. So in such situation, creating a protected space, attracting investors, ramping up the industry may make a lot of sense. Not forever. After some period of development, you need to change the setup maybe, but in the beginning it may make sense. Then you may want to switch to the next one, the so-called single buyer. What does a single buyer do? A single buyer is characterized by having one central instance to which all, the single buyer, to which all generators have to sell, and from which all the later, the downstream players, so distributors and customers have to buy. What is the advantage? Well, it allows you to introduce independent investments in generation. Because you have a competitive setup on the generation side. And in the end, this is the production side of the system. So the biggest efficiency gains by forcing players to take more care about their fuel contracts, by building more efficient power plants, the biggest opportunities for efficiency gains are definitely on that side. So with one relatively simple step, because it's a simple structure, you get most of the efficiency potential that you have in the industry. Sounds good? Yeah?
What scale is this single buyer meant? Like
a country? Yeah. Or well, in the generic, in principle, you said the market. But normally, the market is a country. You may also have countries joining. So if you look at the Scandinavian countries, for instance, they were never a single buyer, but they always developed their setup jointly. They had one spot exchange from the very beginning. So you can also do it across countries, provided you have an interconnected system. You can exchange physically. It's possible, but normally it's a country. Normally it's on country base. There are some limitations, of course. If not, having mentioned so many advantages, this must be the model of choice, which is not. One strong limitation is that such a system, you can imagine that the single buyer has an extremely powerful position here, because it's the one deciding everything. Which means it needs to be very transparent and very rule-based. And whenever you have such a central institution which is primarily rule-based, you will always have a race between players trying to interpret the rules according to their advantage. So they will more think about finding holes in the set of rules than behaving entrepreneurial. You may also say it's limited competition. It's a transparent market. Normally you have not many players, so it's also relatively simple to manipulate. If you take capacity out and create artificial scarcity situations, for instance, you don't have millions of players. You have a few players operating power plants. So there is for all of these reasons, there is a certain tendency that this is not the market model with putting most price pressure on the players. You have competition, you have the opportunity to bring in a lot of private investors and have a fair dispatch process. Just a side comment, China at the moment is heavily moving in the direction of liberalized markets. And they don't do it in order to get the cheapest possible electricity prices. Well, I guess they are not against that, but that's not the main motivation. The main motivation is that they have a lot of renewables and they have a lot of old incumbents. And at the moment, the old incumbents take any argument to push the renewables out, either because they say, we are running coal-fired cogeneration plants, it's must run, we need to deliver the heat. So they have a lot of curtailment, not because of technical reasons, but because of such discussions. And one of the motivations for introducing markets in China is to have a transparent, visible dispatch process, a fair one, hoping that that will result in better utilization of the new players, giving a level playing field of the new players. So it's a fair dispatch process as a side effect. It's transparent, fair, but not the most with the highest possible competitive pressure. China goes beyond that, by the way. China ultimately wants to have a retail market. But it's another opportunity of competition, that you have objective, neutral market processes if you do it right. So again, not the strongest competitive pressure, which makes that market model quite attractive if you are in a rapidly growing economy. As in a rapidly growing economy, the biggest problem obviously is not the electricity price. If that would be a problem, the economy wouldn't grow. So it grows. Obviously, they don't have a problem with the cost base. But a problem that they definitely have is ramping up generation capacity fast enough. That's the rare resource. So if you introduce a market scheme which is open for private investors, but not that with not such intensive competition, it's attractive for investors, and so it may make a lot of sense. It's easy to enter the market, and it's not so hard competition. Again, for a period of strong growth, not in a saturated market. There it doesn't make sense. Then we come to the next one. If we come, wholesale competition. And that's the first. What we had so far were so-called, I call them the unilateral models, because there you still have, well, in the first one you have, as I said before, all the contractual relationships are very clear through the network operator, owning also generation. In the second one you have this one central instance clearing everything. This is the first model where you don't have a central instance anymore. So here players can do peer-to-peer trading, and that means it's another level of complexity. So it's a partly open market. So distribution companies may buy from any type of wholesaler, so they have a full choice of their supplier, and that's a big difference to a single buyer where they had to buy from the single buyer. So there is and that means there is competitive pressure on the wholesale market level. And that's why the differentiation between this model and the next one is not super sharp. Selected customers may also be allowed to choose their supplier, and selection is usually by size. So you can start with allowing only very big industrial customers, then it's not very competitive on the end consumer level, but the smaller you make the customers that are allowed to participate in the wholesale market, the closer it comes to a fully open market. And we have, for instance, UK, for instance, opened the market in 4 steps, if I remember right, beginning with only very big industrial customers, so that was close to that one, and then step by step increased the number of consumers that were allowed to participate directly in demand, and eventually resulted in a fully open market, which gives also the opportunity to learn step by step, because you increase the complexity, so there may be reasons to be a little bit careful, not open the market in one step. What has to be mentioned compared to the others, here we have a significant increase of transactional costs, additional costs because of the administration of the market, depends on the number of players you allow. And here we also have an additional institution, spot markets, central marketplaces, which is just an additional institution. And if you add it, it causes additional cost. So another important thing is, you may say this is the market model where the cost of risk are for the first time with the generators and not with the consumers anymore. So what are the cost of risk, you may wonder, and why have they been with the customers before? Well, the cost of risk means, let's talk about the technological risk, also market risk. Now let's discuss the technological. Technological risk means if you have invested in a particular technology. We are talking about long time investments here, so you have to live with that for 20 to 60 years. 20 to 60 years is a long time. So let us assume after 10 years there is a breakthrough invention. It doesn't happen that often in power technologies, but let us just assume there's a breakthrough. Like, for instance, solar PV all of a sudden is cheaper than any other type of power plants, which happened in the meantime. No one had foreseen that 20 years ago. Honestly, even 10 years ago, we didn't believe in it. So now all of a sudden you have a totally new player in the market. It's cheaper than anything else. Your competitors will use that. What will happen to your investment? well, it has a problem. You will be hard to find a job for it anymore. So it most likely will not pay back completely. So that's a risk that you take whenever you invest. In the old world, in the monopoly world, how would you have solved that problem? Well, there was no need to invest in the new technology before you had earned your money. And that's why I said the customer was paying for that risk. You just waited, because there was no one forcing you to take action. In a competitive market, you don't have that choice, because somebody will do it. And your customers may switch. So you have to choose between a loss-making price or no income. Both not very attractive compared to the monopoly time. And all of a sudden you're sitting on the cost of risk. They haven't disappeared, of course, but the allocation is different. And so you may say the problem is there, and in the end somebody pays for it. The difference is that in the monopoly system, the end consumer was paying, and now the investor is paying. But it's paid. Somebody has to carry the cost. Why does it make more sense that, or maybe it doesn't make, but why could it make more sense that an investor takes the risk? Sorry? They can afford to. Yeah, okay, but well, the end consumer also could afford. They were not asked, but they could afford. The end consumer hasn't the chance to influence it. So the risk was taken by somebody who was not involved in the decision-making process, and that is a strange idea. Whereas if the investor who is deciding to take the risk has to live with the consequences, you may assume that he thinks better about it and reflects, and that in the end it results in a more robust decision. And that is very often, if you talk about business models, market models, very often it is about combining taking the risk and closing the loop, so that the one who is taking the risk should also live with the consequences. And then you assume that he will take, of course, as a professional investor, he should be the best one to deal with the risk. So overall, the risk management should be better. The risk doesn't disappear, but the risk management should be better. That is the assumption. And we will see that again, and that's, by the way, the one of the fundamentals of the idea of a competitive market, that players taking the risk should be the best prepared to do so, and by that overall risk management should be better, and that means overall efficiency is better. Another uncomfortable truth for policymakers, and some of them were not really prepared to that, is in such a system you have less opportunities for direct political influence. You cannot tell a particular group of players that they have to invest more than legally required, for instance, in clean air technologies or so, because they will be not competitive. So if you want to achieve something, you only can do that by defining the market rules. In the case of clean air, it's relatively simple, because you can set the standards for everyone, and then it's part of competition. And but there are other examples where it's not so obvious. For instance, if you want to stimulate, let us stick with this example, cogeneration. You want to stimulate that. How do you translate that into laws? To create a market. So it's not so obvious, and that is what policymakers had to learn. An open competitive market can only be influenced by market rules, and that always implies the risk that the players will conclude something unexpected from the rules, do something which was not intended, and maybe not meet the objectives. So it's more complex to manage such an industry than just by being able to tell them. Well, and the fourth, full market opening is, you may say, only the extreme application of this one, when you allow everyone to choose the supplier, and that has been, well, it is still the favored approach in quite a lot of countries. North America was one of the early movers, not all over the continent, but there are some states which did it from the very beginning. Australia was very early, and well, that's not by incident. Maybe I should change the sequence. Well, that's not correct. Within Europe, there were some early movers which were definitely ahead the European Union, and one of them was Great Britain. And Great Britain was one of the first countries to privatize and liberalize its electricity market, and then Australia followed with a very similar setup, and of course because of the still close relationships historically originated relationship between the two countries. Within Europe, Scandinavia was the second early moving group, and then the European Union as a whole followed. And there we have the answer to your questions. It's although, well, sometimes in the late 90s, early zeros, you could have the impression that this is the model of choice that ultimately everybody would strive for. It's not without of problems. And the biggest problem is the significantly higher additional cost because of more complex contracts, and particularly because of a very complex market-wide clearing process with all the small players. And well, I was pretty polite for saying the additional cost may overcompensate the efficiency gains. I would say in most of the setups today, because we don't have an adequate IT infrastructure, still not in place, a metering, it's primarily metering we are talking about here. I'm pretty sure it's not the optimum. Not today. At least not a pure, if you only look at economies. So I would say this is a good point, a little bit late maybe, but still better than no break, to have a short break, maybe until 4:05, and then we'll continue. So, then let's continue. If we now look at, from here on, we will now talk about the retail competition model, and particularly in the way how it is implemented as a reference in Europe, primarily. Well, we also will discuss a few others, but not in that level of detail. But for any of them, we need to introduce some important terms, and particularly important is the understanding of tasks and roles. If you remember, I mentioned earlier today that although liberalization means that we split up the business along the value chain in many independent actors, we are still talking about a technically integrated system which needs to be operated as one system, and which requires a number of services in order to run stable. So if we talk about tasks, then this is all of the tasks, all of the activities or functions that need to be executed to make such a system work. Both on the market side, you may need market roles in order, more commercial roles in order to make a market feasible, but you also will need technical activities to make a system run. And one obvious example is somebody needs to take care about the physical operation of the entire system. And that's a so-called system operator. And you have never, I guess you have never considered about contracting a system operator when you signed your electricity supply contract, but implicitly, of course, you're funding him. You're not asked, it's a monopoly role, but it's clear that there is a need for it. So tasks are all the activities that we need. And then talking about roles, Roles are the smallest aggregation, you may say the atoms of the system, aggregation of such tasks that are in themselves a possible business case. So that you can run them as a standalone business. It does not necessarily mean that all of the roles are implemented as standalone businesses. There are sometimes synergies between several roles, same competencies, so that you may find them combined in one company. But in principle, you could run them independently. Why does it make sense to identify these roles? You may say that's the smallest possible building blocks of a market, and they're quite generic. So you will find them more or less everywhere somehow, even if they are hidden in particular company setups. And on the other side, you may assume that although there may be some synergies or analogies between some of them, they have all particular skills and competencies that you need. So if you want to understand, if you're an actor in the market, it's quite important to make yourself aware which role you are in, because that tells you also what skills you should focus on. And then you may now wonder, well, if I join a particular company, they know what they do. That would definitely be the case if they had grown like that from the beginning. But although the process of liberalization in the meantime is 25 years old, there are still companies that with a mindset which is somehow linked to the monopoly times who have still not yet understood what it really means to be active where. If you look at, not all of them are fully unbundled. Normally you have, and you will see that later, for instance in Germany, but also in some other European countries, all over Europe, you have it is allowed to keep supply business, so the competitive part of the business and distribution network operation in one company below a certain size. And in fact, in Europe, it's below 100,000 customers. 100,000 customers is not inhabitants. Customers is quite a lot. It's a mid-sized German city. Normally, you can say 300,000 people inhabitants means roughly 100,000 electricity consumers. So it's not a small city. So many of the municipal utilities in Germany or Austria or those countries with this traditional municipal structure are below that threshold. So they're not forced to unbundle. And they have never really understood what it means. So in such environment, it's important to understand where you are. And the closer you are to the process of marketing opening, the more relevant it is, because it's all new for the players. So if you now compare, you may also apply this term roles, although it wasn't used, to the monopoly world. And if you then say before liberalization, the roles were more or less completely derived from the technical process, and afterwards they were more linked to the particular task. What do I mean by that? If you look at, a good indication is, if you want to understand what priorities a company sees, what makes them special, how they form trade associations. Trade associations usually should be associations of similar companies, because they have similar interests and want to express them against policies. So if we look at the associations in Germany before liberalization, then we had an association of the so-called interconnected utilities. So they were obviously the ones running the transmission network, interconnected to neighbors, but they were also owning the majority of the generation capacity, 80%. So that was what defining them. A very high voltage level and bulk power plants. So technical. Then you had the so-called regionals ones. They were operating the 110 kV network, sub-transmission networks, and a little bit of generation. And then you had the municipals, which was normally also more than electricity, because they may also run heat networks, gas networks, public transportation. So a little bit more diluted focus. So you may say at that time the voltage level more or less was defining how a company saw itself. and it's pure technical. In a liberalized market, it looks a little bit different. So let us start with that. And you may say, although we have colors now and we have a lot of free space on the slide, which we will need, but in principle that's the same what you have seen before. You have the transmission level with the power stations, you have distribution level, and you have the end customer. And you have a very simple, you have a clear link between physical flow, the yellow one, and contractual relationships. And they were static. As I mentioned before, you knew the entire supply chain if you knew where you lived. Your house, your place of living defined your entire supply chain. No need to think about anything. Maybe about where to get the money from to pay the bill for. What liberalization did is, first of all, it removed the contractual relationships and replaced them, of course. It did not change the physical system. Well, I introduced that slide in the early days of liberalization, and in these days I can tell you it was very important to stress that. It's still the same physical system, which means that has some consequences. It replaced the contractual side of the business, and well, at some time we should see something showing up. Either we have a power problem now, or no, we had for whatever reason, the window switched. We have the main economical process, you can say, around energy as a product. And what we see first is that power stations all of a sudden have to trade their capacity. It's not for granted that they are dispatched. They have to sell their capacity. So it's still a power station operator, but all of a sudden he has to have a sales department, a trading floor. He will sell his capacity into a wholesale market primarily, where he may deal with others, peer-to-peer. He may also, there it is, use a spot market for to optimize his portfolio. He may also secure things on financial contracts on financial markets. He may use financial services to hedge physical risks, which is something monopoly players never thought about. They could have, by the way, because they also had financial risks, because they were also depending on fuel markets, and fuel markets have always been risky. So they could have used this, but they never did. Again, remember what I said about who is paying for the risk. It's easier to ask this one to pay the risk than to deal with strange financial markets, particularly in engineering-dominated companies. And I can promise you, they were dominated by engineers. Well, then you have the function of the wholesale market is primarily to optimize portfolios. So they're trading back and forth, but not with the direction to the end customer. The end customer comes into the game when it goes to the energy service provider. And there are different terms for this market role. Another one is retailer or supplier. And with this picture only, you may wonder why the hell it's called energy service provider. So well, it's a supplier. It's the one from which you buy your electricity. It's the one with the end customer customer contact. If not, an aggregator is in between. So you may have also roles that combine a lot of smaller customers, for instance, to give them more buying power and bring them to the market. An aggregator may also be, and that's at the moment, I think, the more common use of the term, one contracting distributed resources on the generation side and bringing them to the market as one virtual power plant. So, as the objective of this entire market setup is to create competition as much as possible, to make by competitive pressure to increase the efficiency of the overall market. This process should be as simple as possible. It's not very simple, but as simple as possible. It's definitely not a good idea to transfer all the complexity of a real-time operation of this sophisticated technical system into trading. Because then nobody would trade. If you have to consider, so what is traded here is normally it's time series with a certain resolution. In Europe it's 15 minutes, in other markets it's half an hour. You may also do it hourly, but relatively simple. The products are, compared to the complexity of the real operation, the products are relatively simple. So they should not be misleading. That's why we have time series and not constant production or something like that. Some reflection needs to be there, but it can't be too complex, because the more complex it becomes, the less actors will be able to do it, the less liquidity in the market. So there's a natural conflict of interest between running this complex system as accurate as possible and making trading as simple as possible to invite as many players as possible. And well, that's all fine as long as you don't need to operate the system, but at some time you need to operate the system, and then you need to close the gap. And that's why we still have some space, free space. There are some additional market players. And the main purpose of these is translating the relatively simple trading result into real operation. And they are, first of all, the administration of network access, so defining who is working with whom. It's an that's a primarily administrative role. Then we have the so-called, we have metering, because we need that information. Then we have a very central role, the balance responsibles. And the balance responsibles have the tasks to translate whatever has been decided here, both on generation and consumption. You may say the result, the physical result of this process is a rough estimation of generation schedules and load schedules, a rough. But in the end, you need them as accurate as possible. And the task to make them as good as possible is the main task of the balance responsibles. So they have to improve the forecasts of load and generation. It's an additional service. It's, by the way, normally not a very cheap service. So deviations are quite expensive in order to educate the players down here to work as accurate as possible. The more, well, it's in quality management, you usually say do it right from the beginning. And that's the same what applies here. The better the original trading result is, the easier it is to translate it into real operation. That's the main task of the balance responsible. Well, and then on top of that, we have the system operator, who is in charge of consolidating all that input and running the system stable. And we will discuss all these roles in quite a lot of, in a certain level of detail during the rest of the lecture in the coming weeks, each of them. What you also see is there are a number of services which are monopoly roles. And normally you can say, well, metering is a gray zone. It can, this could also be a competitive role. In some market it is competitive. In the majority is not. In the majority it's linked to distribution network operator. We will discuss that shortly later on. System operation and also network access are services which you may say wouldn't be well, in case of system operator you need one. So there's no chance, you need physically one instance being in charge for that. So that has to be a monopoly service. And network access management, the administration of the market, does also not make sense to have. It's a service that you need. You need to know who is doing business with whom, but it is not a business that you would run self-motivated competitive. So that's why it's installed as part of this monopoly service in order to make the market work. Well, it's a little bit more complex than it used to be before. Some more roles, but it's even not the full story. Because if you remember the first version of this slide, the one with only the yellow, the physical parts, and the one business process, I said it's static. This is dynamic. So at least all the gray market roles are competitive roles. That means many of them are there, not only one. And the business relationships between them may change, well, depending on the market rules, but normally at least every month. So it's a little bit more complex than before. And this may be another reason why liberalization evolved in the 90s and not earlier. If you cannot run at least the B2B part, all the relationships between the players, maybe not that interface, but all the rest, the B2B means business to business, so the processes within the industry, electronically and automatically, this will never pay off. So the evolution of information technologies certainly was an important enabler for the concept of running this system liberalized and competitive. So you may wonder what that means, because you have never, unless you are not highly interested in the subject, sorry. Why these are together? The question is why these. That's a thank you very much. Very good question. It's also not everywhere the case. It's the European view, where we talk about TSOs, transmission and system operators. In fact, these are two different tasks. So running the transmission network infrastructure, maintaining it, planning it is one thing. Running the system is another one. And in the US, for instance, you have the concept of the independent system operators, and the independent expresses exactly that. That's different roles, and you have multiple transmission network operators in the same area. You may have at least. Here not. Historically, the reason has to do with, you may remember this slide. The reason is this 80%. The reason is that the majority of the system operator is very much about coordinating the power plants, load dispatch, while keeping the system in balance. So the most important asset the system operator is working with are the power plants. And as them traditionally have been connected to the transmission level, the majority, this has been seen as one role. We are now currently in a transformation where the majority of generation is moving down to the distribution level. So more than 90% of the renewables in Germany are connected to distribution networks. So far, they haven't been part of system operation, so they have been not actively managed, but it's easy to foresee that that has to be changed. And then this logic saying, well, it's all connected to the transmission network, so it makes sense to combine the rules, may be challenged. And there are countries where it is challenged already. So UK, for instance, the National Grid has separated system operation from network operation. It's still under the umbrella of National Grid, but it's two companies in the meantime. So that was a very good question. There's no natural law saying that this has to be combined. It's a tradition which evolved from this fact that 80% of the actors the system operator uses are connected to the transmission grid, but as that is subject to change at the moment, that may be changed. There are a lot of discussion on how DSOs, distribution network operators, and transmission network operators should cooperate, and it's primarily on this question. Let's see where that will end. What I wanted to do now is, if you're not familiar with the subject and see that for the first time, you may wonder where do you see that? What type of companies are? So let's translate that into the situation of a customer in Aachen. Any of you? So the first one, where you don't have a choice, is your distribution network operator. And that's InfraWest today. By the way, some years ago it was still called Stavak Netz. And there is a directive coming originally from the European Union saying that the network operators are not allowed to carry the same name anymore, like the, well, you may say sister company in the energy business, to make people aware that it's two different things. Because there were network operators that were playing with that. I remember there was a radio ad in the region where I'm living, where the local network operator was, why should a network operator, a monopoly role, be on a radio ad. So it was obviously on behalf of the competitive business with the same name. And the whole message was, we are everywhere local, we do service for you, our people are there, and that's why you should, which is totally misleading, because the service people normally are the people in the network, and they are there anyhow. So they have to serve you anyhow, and they were playing with the fear of people that if they change supplier, they will not be served anymore in case of a disturbance, which is wrong. It's really wrong, because the local network operator has to offer this service to everyone. Otherwise, it's discrimination. So that's the reason why they insisted in having different names, that people become more aware that this local physical service is one thing, and it has nothing to do with the choice of supplier. The other one where you also don't have a choice because you're living here is the local transmission network operator, which is Amprion, which, by the way, some years ago was called RWE Transmission, and now the same story. Although they have only a minority share of RWE, and RWE is only holding a minority share in them, and they have divested. On the supplier side, you have a choice, and typical suppliers here in this region, I would say, well, there are some local, of course, Stadtwerke Aachen is one of them, the municipal player. Then I have put in here the one from Cologne, and 3 examples which are active not locally only. Yellowstrom was the first supplier who was active all over Germany. E.ON is one of the big ones, and RWE I think you have also heard about. On the wholesale side, you will find other players, or the same. So RWE or E.ON are, of course, also active there. So here you see primarily the traditional big ones, so the 4 big ones, because wholesale is a business where you need size. Size matters. And that's why all of a sudden you find another player here called Trianel. And Trianel is an initiative, as a company in the meantime, it's a pretty big company, but originally it was an initiative of Stadtwerke Aachen, so they were in the lead. Very early, so they had understood very well, forming an alliance of, in the beginning, I think 35 municipal utilities to form a trading company in order to get size, because as a municipal player on the wholesale market, you're nobody. And that's a good example that somebody understood the role and adapted his market approach accordingly. And it was very early and pretty successful. And they started as a pure trading company, so basically bundling their sales, their purchasing power, and then also began trading. And later on, they also started to build own power plants, because it turned out that being a trader without physical assets is a very volatile and risky business. In the early days there were some, but over time only those with physical assets survived, so they did that. So that was a quite impressive example. You need a balancing circle. The energy service provider will organize. That's, by the way, why I called it energy service provider, because the energy service provider is bundling all the services that you need, that are required to make your supply happen. That's why you don't know about all these other services. You don't see them, but they contract them. And balancing circle can be independent or not. Balancing circle is also a business which requires some size, but in principle, Stavak is a supplier which is big enough to do that on their own, but they may also contract it from somebody else. Well, we have one power exchange in Germany, and in the meantime, across most of the European country, there was a strong consolidation, which is the European Energy Exchange, with main locations in Leipzig and Paris. So if they want to trade there, they will use these platforms. Well, and on the generation side, again, you see primarily the big ones. It's here the examples are the same ones. So these are examples. There are, of course, more. Where you see the same players here for the same reasons. You need a certain size. So if you sign your contract here, all of that happens. And you never heard about it before. So now you know what you have done. The balancing circles can be multiple. So it's a competitive offering. It's a service provider. They have a number of generators or retailers under contract, and improve their forecasting and hand that over to the system operator, which is then who is then consolidating all of that input, and in case there are still deviations, sorts them out. And
That's the part that I was ultimately the system operator is responsible for the frequency.
yeah, that's physically it's him. So what the balance responsibles are doing is improving schedules and forwarding them to. So you may say it's a bigger statistical collective than the individual players. That's primarily the mechanism, so that they see more. And in principle, there are many retailers or service providers who run their own balance circle. So this is a typical example. I'm not aware of any standalone balance circle. Normally it's a service within a retail company, but which is also offered to smaller ones. So there are retailers who are not having their own balance circles, but I'm not aware of a standalone balance circle operator, because that's a very volatile business. It's possible in principle, but very risky. So the next slide summarizes the type of skills that you need to run these different roles, and considering the fact that we are over time already now, I don't want to read all of that. I hope you can also understand it based on what I've said before. What I would like to make you aware is of the color code. We have here dark gray, which are the competitive roles, commercial ones. We have light gray, standing for service IT related ones, and we have yellow roles, which I would say which are still primarily technology dominated, like the industry used to be in the monopoly time. And the main message of that is, well, there are still roles where that is important. Don't underestimate it. But in the majority of the roles, other skills are relevant. So the industry has become much broader. The variety of skills that are required are much more today, which is an adaptation process which is not easy. Some of them have done better, some less. In many cases, if you look into the details, you will see that ICT, so information communication technologies, play an important role, and this is not the tradition of this industry. This is not an ICT industry. So that is still a challenge. By the way, the same in our engineering companies are not necessarily IT companies. So it's a challenge that is still not solved, I have to say. And the other thing is skills like risk management, business process design play an important role today. Most of them are service business, and most of them are service businesses and not running assets. And that's it's really new for this industry. So I would suggest to stop here. Next time we will go through international examples, what has happened all over the world, and then after that we will discuss in detail what the different roles are doing. Thank you very much for today, and see you next time. And first of all, have a nice weekend.